So here we go. All right, welcome back to week number 2. And this is a topic that will finish off significant figures. So this will be a little bit of review. If any of you have already completed your quiz, this doesn't apply to the quiz. If you haven't completed the quiz, this might give you any little extra help that you might need. So the only thing that we didn't cover last day is what do we do if we have multiple operations? A lot of time in chemistry, you will not just have adding and subtracting or multiplying and dividing. You will also have combinations of those. You might have to add some numbers together and then multiply them by something else. None of them are that complex. In chemistry, especially first year chemistry, we don't really have any crazy mathematical functions. It's usually adding, subtracting, then multiplying or dividing. So pretty straightforward. So what you do is you follow your order of operations, which I will write on the next slide if you give me a minute, and you look at your significant figures after each operation. The key to this for a proper calculation is you make a note of significant figures, but you only round your number at the very end of the question. So what you can do is you can underline your significant figures or write non-significant figures as subscripts, and I'll show you in the next example or two. Before I do that, just a little heads up, I guess. If you can't remember your order of operations, it's like this. You do anything that are in brackets first, then you do your exponents, then the next two you can do in any order you choose. So that's divide and multiply, and then the next two you can do in any order you choose. So you would simplify anything in brackets first, then do exponents, then you would divide and multiply, and that's any order you choose, and then add and subtract, bed, mass. And again, some people in different school systems, like maybe British, you might have learned PEMDAS, P meaning parentheses. I don't know if I spelled that right, but that's the same as brackets. So if you are familiar with PEMDAS, P and B are the same thing, brackets. All right, so here we go. If that was a little too fast for you, my YouTube playlists are active, so all this will be up on YouTube after. So here's a complicated kind of example. Here I have multiplication, subtraction, division. I also have two sets of brackets, as you can see. So the first thing I would do is worry about my brackets. So I'm going to simplify this step in the middle. Now you might think, wait a minute, subtraction is like the last thing, but remember, it's inside brackets. So I'm going to do the brackets first. So I subtract, we take the lowest decimal place. We have 1 decimal place, and here we have 2 decimal places. So over here in the next section, when I do that on my calculator, the calculator will say 7.25. So I just made a little note for myself that 7.2 is all I can do. Okay, next step. I'm still up here. I'm going to multiply these two numbers together. When you see two numbers that are in brackets together like this, that means multiply. So these two numbers get multiplied, and I know I can only have two significant figures. Remember, when you multiply, you use significant figures. So that brings me down here to the next slide, or next line, I guess. I have two significant figures. You'll note I didn't round my number. And now I just divide this, and it has to be two significant figures. So there's my answer as two significant figures. And it's all because of this number here. My weakest measurement is basically the answer, or the number of significant figures in my answer. So if that's a little confusing, this would be a lot better maybe in the classroom, but I mean, it's all we can do. We're online for the rest of the year, or well, for the next few months at least. I would like to give you guys a couple minutes. I will mute myself, and I'll give you 2 minutes to try these 3 questions. And this, this, by the way, is division. It's not written that clear, but it means division. So I'll give you a couple minutes. I will mute myself. And yeah, good luck. I'll be back in 2 minutes. All right, so let's look at the answers. Feel free to write the answers to A in the chat, and I will look or put up the answer now, but I want to explain where the significant figures come from. So the answer I'm getting for this, my calculator is giving me a crazy big number, and I'm seeing in the chat at least 2 correct answers. 243 is the answer. So, and I'm seeing, you know, like 242.9 and things like that. That's not the wrong answer in terms of the actual answer, but it is in terms of significant figures. So why is it 243? Well, the first thing I do, the first thing I do is my brackets. I add these 2 numbers together. So this will give me 1.21 grams per milliliter. You don't have to worry about units for right now. And this answer over here, this is actually given to me by my calculator correctly. My calculator gives me the proper number of significant figures here, 200.765, and that would be milliliters. All right. Now, this one's pretty easy. Okay, so yeah, these are all significant. I have 3 decimal places, that's fine. But now remember, I'm multiplying these numbers. And this 121 only has 3 significant figures. So my answer has to be 3. So my calculator is telling me, let me change my color back to red. My calculator gives me 242.925, it goes on forever, but I would round that to 243, and then I would use grams as my unit. But you guys don't have to worry about units just yet. So the answer is 3 significant figures. So it would be just 243 grams. All right, let me check the chat. Cool. Yeah, and it would just be grams as my units. But guys, you don't have to worry about units for now. We'll talk more about units in chapter 3. All right, let's do the next 2. I have to erase my work because I don't have enough room. So make sure you can take a picture or a screenshot, or just watch the YouTube video. But I do have to clear my drawings here. Or try to. There we go. And we'll do the next 2. I'll do the next 2 pretty quick. So feel free to share your answers. I'll have a look at the chat in a minute. Again, you guys don't need to worry about the units. Okay. This would be units grams per milliliter. This one's pretty interesting. So here I would divide first. So I would do this part first. So I would get 320.5 grams per milliliter, and I would subtract from that whatever my answer here is. I'm going to do it on my calculator now. It would only be two significant figures. Oh, I'm going to get a negative number here. I should have changed that. Oh well, doesn't matter. 6, I want to make sure I entered that in right. I think I did. Let me just do that again. Not the most entertaining YouTube video here. Yeah, okay. So my answer that I get is 2,654.13. I'm not going to write every decimal. But guys, this number only has two significant figures, okay? Because this number only has two significant figures. So when I subtract, this is an interesting one. This is, because we really got to be thinking here. When I subtract these numbers, first of all, I am going to get a negative number, which doesn't make sense. You can't have negative density, but oh well. But I need to count my decimal places. So I'm going to subtract these numbers. Okay, and I end up getting my answer as negative, 2333.63 grams per milliliter, but I can only have, this answer only gives me two significant figures. So that means my answer, and this is where it gets real weird, my answer will have 0 decimal places. If this top number is only significant here, it has no decimal places. Oops. So my answer will have no decimal places. And I know I have decimal places written there, but it's only because I didn't want to round my number until the end. So this tells me I have no decimal places. So it would be negative 233 point, that's it, not point, just grams per milliliter. So let me look at the chat. Yeah, actually, sorry. Yeah, a seal actually gave me the correct answer. Technically, I should round up, shouldn't I? Because I'm rounding at the last decimal place. So yeah, that should be a 4. My bad. I noticed that as soon as I saw a seal write the answer, 2334, because I'm rounding up because this is a 6. So no decimal places in my answer because this is my least significant figure and it has no decimal places that are counted. None of these decimal places are significant, so I do not count them. All right, that was a tricky one, and the number didn't really make much sense. All right, so let's go down and do this last one, and then I'll very quickly move into the next topic, and we'll take a break for today. So here we go. I have 2 sets of brackets. So what I would do is I would do this first, and then I would do this one second because it's in these brackets. And then I'll multiply it by the other number. So first things first, 0.863 times square bracket 1.255. I'm talking to myself here, minus this number. Now this number, and feel free to share your answers in the chat. This number would be 3 significant figures. Okay, because this number has 3 and this number has 3. So whatever I write down here, 372 8.6, only the first three numbers are significant. Okay, so now what I'm going to do is subtract the numbers. So 0.863, I have a square bracket here. There's no difference between a square bracket and a round bracket. It's just, for organization purposes. I see the chat going crazy up there, guys. I'll have a little look once I get the answer here. I have to use a different calculator. 255, exponent 3. Now, this is actually a little moment to talk about something here. Be very careful when you're using scientific notation. Make sure you use the proper button on your calculator, whatever calculator you have. For me, on my Android phone, I actually have to type in times 10 to the 3. But if you have a graphing calculator or a scientific calculator, you would use your exponent button. So I subtract those numbers. Now my answer, guys, will be 882.4. But I can have no decimal places. Remember, I'm subtracting. This one has no significant decimal places. This guy over here has 3 decimal places. So my answer is only significant to, again, 3 significant figures. So I multiply it out. This is the easy part. I'm pretty much done. Times 0.863. And I get my answer, 761.5112, and I round it to 762. These are, guys, these are challenging questions. I'm getting people saying like 761, you're very close. We would just make sure we round it up. If you said 761 on a test, I would give you full marks, but the correct answer is 762, which I do see in the chat a little bit. For anybody finding this hard, don't worry. We will cover this more in chapter 3. When I get to the calculations, we will do this in chapter 3 a lot more. If you need any extra help, you can always check online. I have some worksheets with answers that I'll be putting up this week, so you can use those for your first test. The worksheet will cover Unit 1, and we're pretty much halfway through, or more halfway through Unit 1. So again, I'll leave it there, and I'll just introduce the next section. These are some resources you guys can use. The links are there. You can click on them. If you go to D2L and open up the PowerPoint, you can click on these links. They should still work. You can see they're a few years old, but Khan Academy and Crash Course are 2 very reliable YouTube channels, and I think they're still there. So if you'd like any more videos or instruction, these are 2 examples. And this is just a little summary of significant figures, which I'll leave for you guys to read or look at on your own, just like a little, almost like cheat sheet of, what's significant, what's not significant. So just a little summary there for you. All right, I think basically I'll just take 5 more minutes and introduce the next section, which is might be a little more interesting to you guys. I had a question in the chat, when is the next quiz? The next test is on your syllabus, your course outline. The first test will be in week 7 or 8, depending on our progress. And quizzes are usually every week or every week and a half. So I'll let you know when the next test or quiz is for sure. Okay, but there is a quiz due tonight, and your tests are due, or we will have tests in week 7 or 8. I think it's week 7 for now. So yeah. It's all on your schedule. If you guys read your course outline, it'll tell you when your tests are. Um, Quizzes are usually every week, week and a half. All right. So this is a really important section, and for any of you in class who aren't big fans of calculations or significant figures, this is a little more straightforward and very much an introduction to chemistry in general. We'll talk about the difference between elements and compounds. We'll talk about chemical symbols, how they're written, and we'll talk about this law of constant composition. So sounds complicated, but it's pretty easy. So I think today we'll just have a nice quick little section. I'll just cover maybe 4 more slides. I'll get to slide 43. Take me just a few minutes and we're done. Okay, so here we go. An element is a pure substance. And what that pure meaning, it's not a mixture of 2 or more things. Something that is not pure is a mixture, 2 things put together. Like milk would be a mixture, or tea would be a mixture. If you guys drink tea or coffee, it's water with something dissolved in it. An element is pure. It is one thing. It cannot be broken down by chemical reactions. It's made of small particles called atoms, which we'll talk about in the next section. So elements make up the periodic table, and humans have discovered 118 different elements to date. The first 94 are on, now these don't add up. I think I have to change my number here because the last few elements to make us up to 118 are kind of new. Oh no, that works. Okay, so the first 94 elements occur naturally on Earth, and the remaining 24 are synthetic. And I have a periodic table that I'll give you guys in your, well, me and or whoever your lab instructor is can give you in your labs. On our periodic table that we use at the college, we have it we show you which ones are synthetic, meaning they are made in the lab, but 94 of all of the elements that we have discovered in the universe, you can actually find naturally on Earth. So in the atmosphere, in rocks in the ground, things like that. So all elements on the periodic table have names and symbols. Now, if any of you have done chemistry before, this is like, first year chemistry, this might even be like junior high science, but it does get a little more complicated. This is more for any students who've never done chemistry or haven't done chemistry in a long time. So all elements have names and symbols to represent them, and some symbols and names, some symbols come from their English names. So hydrogen and carbon, hydrogen, the symbol is H. Carbon, the symbol is C. Pretty straightforward. Some chemicals or elements are very, very old, like thousands of years since they've been discovered. So their names are a little older. They can be Latin or Greek. I think tungsten might be from German. There are words in chemistry we'll learn later that have Arabic roots. In organic chemistry, there's lots of Arabic words that might not mean anything today, but they're taken from old Arabic words. Like chemistry, for example, comes from alchemy, which is a very old word. Alchemy back 1,000, 2,000 years ago would be almost considered magic, where you would turn an element into something else. And from alchemy, which from what I know has Arabic roots, we get the word chemistry. So, if you're looking at the periodic table and you're thinking, why is gold AU and why is silver AG? That doesn't make any sense. It's because gold, the chemical symbol AU, is from the Latin word aurum. Silver, argentum, AR, right? Or ARG, so they call it AG. Mercury is HG, from the Greek hydrogurum. It's hard to say. There's a lot of different words or different symbols that have really old meanings. So if you ever see a symbol on the periodic table that you know, like why is lead called Pb? Chemical symbol for lead is Pb. I think it's from Latin or Greek. I can't remember which one, but it's plumbum. Silly little word. So they can be a little hard to memorize. And you guys need to know the names of basically the first 20 chemical elements, and you definitely will need to know the names of some of these metals in the middle. And we'll do a review of these names a little later as we get through the course. Okay, so I'll give you like a little list of all these chemicals that you need to know how to name. I won't name them all today, but in Unit 2, when we look at the periodic table, we'll look at the names of all of these things. Okay, but these ones that I have written here in black, these are some of the ones you need to know. This would be uranium. That's a radioactive element. Oxygen, cobalt, calcium. You need to know most of these. And it's a lot easier than it looks with a little bit of practice. So 2 more slides and I'm done. We started a little late today because I had to talk about the lab, so I'm sorry for going a little long, but just 2 minutes or so, we're done. This slide, you know, what do you notice about how these chemical symbols are written? The real, like, just to kind of speed things up here, because I have a class now in a few minutes. Really what you should notice here is the chemical symbols are all capital letters followed by a lowercase letter, okay? If it's just one letter, it's just a capital letter. We would say uppercase letter. If the chemical has 2 letters, the next letter is lowercase, or not capital. And that's really important. And this is the last slide I'll talk about today. All chemical symbols are written the same way, and this is extremely important. The first letter is always capitalized, that means uppercase, and the second letter is lowercase. Now, why, right? Why does that matter? Well, on the periodic table, carbon is C, capital C, big C. Oxygen is capital O, big O. Cobalt is written as C, lowercase o. So it's really important that we don't make this O uppercase, because if you wrote cobalt like this, that's actually carbon and oxygen. Oops, this is a mixture, or it is a mixture of elements. I guess what we would technically call this is a molecule. Whereas these guys over here are elements. And again, if you are writing in the lab or on a test, and I ask you to write cobalt, and you write C capital O, what you're telling me is that it's carbon and oxygen, not cobalt. Cobalt is its own unique element. It has its own, specific number of protons. It's completely different than carbon or oxygen, like extremely different. I mean, it's a metal. So just be really careful in the lab and in like your tests or quizzes, uppercase and lowercase do have a big effect on what you're trying to say. All right, I'm going to leave it there. We'll talk more about this tomorrow or next. Yeah, I have you guys tomorrow. So we will continue with this tomorrow. Thanks everybody for joining in. I'm going to stop the recording now. And if you have any questions, let me know in the chat.